So we're talking about business applications. We're going to use the ideas above, addition, subtraction, multiplication, and division of functions to create new functions, but we're going to do it in the context of business. So let's talk about this. We're going to let X equal, again, the quantity of some product that you produce and sell. C of X is the cost function to produce X units. And in business, if you produce 5 units, that might be a different cost than producing 10 units. So the cost depends upon the number of units that you're going to produce. Yeah. And in fact, often in business, the more units you produce, the cheaper the average cost becomes, which is down below. And we'll talk about that. The revenue that's generated by selling X units is going to be denoted by R of X. And the profit is denoted P of X, capital P of X. Is the profit from selling X units. Now, the revenue is the price times the quantity. So this is another formula for this quantity that we're talking about, R of X. When you generate money, when you count up your money, the amount of money that you bring in from selling units is the price times the quantity. That is to say, 5 bikes at $600 per bike, right? So, where this is called the Greek letter rho. It looks like a lowercase p, but it's a lowercase Greek rho. And do not confuse capital P profit with lowercase rho price. Sometimes this is actually called the demand function in business, right? Demand. And then the major idea here is the profit you generate is equal to the revenue, how much money you generate from selling your products, minus the cost of producing X units for your business. And then simplified, replacing R of X with its actual formula, price times quantity minus the cost, right? So if your kid's selling lemonade, this is the price per cup times the number of cups you sell, minus how much it costs you for sugar, lemons, cups, and the lemonade stand. And then the average cost, denoted C bar, is the average cost per unit. And so you take the total cost for producing a certain number of units, and then you divide by the number of units you produced, and this gives you the cost per unit. So again, when we talk about Army men, the cost of producing 1 million Army men might be large, but when then you divide by the 1 million Army men you have, you get a price per Army man that might be relatively cheap. Yeah? And in fact, the more you produce, it's going to drive your average cost down, because as your denominator gets larger, your fraction gets smaller. So that's a recap of some basic business. I'm going to pull a business application out of here. This book was written by some guys, I think, from like Washington or Oregon, and they're always talking about Sasquatch in here, and I think that's because they're from the Pacific Northwest. But Sasquatch, please. Bigfoot is our word, you know? Okay. So for you hairy beasts out there. Let's talk about an example. This is problem number 46 in your book, and I'm just going to read it to you first. It says, the cost in dollars to produce I'd Rather Be a Sasquatch t-shirts is C of X is equal to 26, or 2X plus 26. So they're telling us in this example, the cost to produce X shirts is C of X is equal to $2 per shirt plus $26 startup fee. And if you run a t-shirt printing business, that is, setting up your silk screens and your colors, and then $2 per shirt involves the fabric and the ink, depending upon whether or not you're going to use simple tees, pocket tees, baseball tees. It's no big deal. Softball tees, I should say. Anyway, that's our cost function, where X is greater than or equal to 0. This is an applied domain. That is to say, The cost function is a simple polynomial. There's no division by zero. There's no radicals involved. But since this is an application, we're not going to be producing a negative amount of t-shirts. Otherwise, everybody's going to be naked. So, and then it says the price demand function in dollars per shirt is given by rho of x equal to 30 minus 2x. This is the price per shirt, and it's got its own domain for 0 less than or equal to x less than or equal to 15. And this is a little bit ridiculous because apparently if you order 15 shirts, they're free. So that's nonsense. But whatever, it's a math problem out of a book. What are you going to do? It's not real life, but we're just talking about the application here. And it says, find the following. Find C of 0. So this is part A. Well, C of 0, this is the cost at $0 or 0 shirts, which is 2 times 0 plus 26. This is sometimes known as the fixed cost. So to interpret it, what this means is if you're going to produce t-shirts and you're not even going to make a shirt, just to get set up, it's going to cost you $26 in startup fees. Yeah? You're going to go to Threadless, you're going to design your own t-shirts, but then you're going to start printing them. Threadless doesn't work that way, but they're going to want $26 to start up and then $2 per shirt. But if we're not going to produce any shirts, this is the cost to do business without ever selling a single shirt. That's our interpretation there. B, find C bar of 10. Well, C of 10 is equal to 2 times 10 plus 26, which is 46. This is the cost to produce 10 shirts. However, C bar of 10 is C of 10 divided by 10, which is 46 divided by 10, which is 4.6 or $4.60. That is to say, the cost to produce 10 shirts is $46. So this is price per shirt. It's $4.60 per shirt. That's the average cost of each shirt when I produce 10 of them. Yeah? Is everybody okay? So far, so good? Okay. C. Find and interpret row of 5. Well, row of 5 is 30 minus 2 times 5, which is equal to 20. Now, this is also in dollars, but it's dollars per shirt. But this is if you buy, or if someone buys 5 shirts, we price them at $20 each. So it's not the price for all 5 shirts. The total price for all 5 shirts would be $100 because it's $5. Sorry, it's 5 shirts at $20 each. So this function is the price per shirt, not the price for all 5 shirts. The price per unit at 5 units. Yeah? So watch out how you interpret that. Find and simplify R of X, so D. Find R of X. Well, R of X is the price times the quantity. And here the price is 30 minus 2X per shirt times X, which is 30X minus 2X squared. And this is the formula for the revenue generated by selling X shirts. Not the profit. If I'm going down to the farmer's market and I'm like, dude, buy some shirts. This is the money that I'm collecting while I'm down there for selling X shirts. It is not my profit. It's not my take home. This is the, ew, Sasquatch is gross. But I mean that in a business sense, right? Gross income. E. Find P of X, the profit function. Well, the profit function, P of X, is the revenue minus the cost. Do not forget to use parentheses here. That's 30X minus 2X squared from above, minus the cost function, which is 2X plus 26. So when we simplify this, we get (28X minus 2X squared plus 26. Sorry, minus 26. This is our profit function. This is the net from selling X shirts. Now, the last part I want to talk about. Part F is about what's called break even, and when the profit is equal to zero. When the profit is equal to zero, this means that you have generated exactly as much revenue as you had cost. That is to say, you're not losing money, but you're not making any money. This is your break even. Now, to clear it, so if you want to make a profit, what you want to know is when your profit function is greater than zero, and you take a loss when your profit function is less than zero. So if you have negative profit, you're losing money. If you have positive profit, you're gaining money, and you're breaking even, as they say, when your profit is zero. So it says, find and interpret P of X equals zero. Now, this might be a little bit difficult for some of you that maybe aren't used to this kind of thing, or remember how to do this from Math 127, but this is a polynomial equation that we're setting equal to zero. And if possible, we'd like to factor that. If we factor out a -2, we get x squared minus 14x plus 13, which is 0. And if we factor that further, we get x minus 13 times x minus 1 equals 0. And that will happen when either x equals 13 or x equals 1. And so what this means is a couple of things. If we only sell one t-shirt, we're going to break even. But what happens if we sell 13 t-shirts? Well, let's talk about what this means. So first of all, if I graph this, X the number of shirts versus the profit, I know that at 1, I'm generating 0 profit. So I have a 0 there. That's my x-intercept. Also, I know that if I sell 13, I'm making 0. Now, from Math 127, this is a parabola. It's a quadratic function, and it opens downward. So that's some review from a different class, but that means that this function looks something like this. I don't know why I made that dashed. But this is just an approximation of what's going on. And so down here, the profit is negative. In between these two values, the profit is positive. And then after 13, the profit's negative again, which means that there are two different spots where we're going to break even. And according to how I'm pricing things, I'm only actually making money if I sell somewhere between 1 and 13 shirts. So this is making money. And then losing money. Now, it might be counterintuitive. You probably think the more shirts that you sell, the more money you're going to make, but not at this model. Remember our price function? Our price function was a little bit weird. Our price function was, we're going to start out at $30 a shirt, but for every extra shirt you buy, I'm going to take $2 off. And we saw that when you bought 5 shirts, we were selling them for $20 a piece. But when you buy 13 shirts, you're only going to end up selling them for 30 minus 26, which is $4 each. And now you're not making enough money because you cut the price on your shirt so much that you're undermining your profit and you start losing money again after that, right? In fact, at P of 15, you're basically giving them away. So this isn't a good business model, but that's what the math says. For some reason, if you get 15 t-shirts, you're pricing them at $0 each. That's kind of a bad business model. But there it is. Yeah, anyway, there's some business examples.